Lightning strikes can induce significant electrical surges into unshielded underground data cables. This poses a threat to connected equipment. Several measures can be taken to protect equipment from lightning-related surges. Firstly, consider using shielded underground data cables for outdoor installations. The metallic shield provides a conductive path for lightning surges. This diverts them away from equipment. Secondly, ensure that the shield of the underground cable is properly grounded at both ends. This grounding provides a low-resistance path for surge currents. This allows them to dissipate safely into the earth. Thirdly, install surge protectors on both ends of the underground cable. These devices redirect transient voltage surges away from connected equipment. Choose surge protectors rated for the specific voltage and current requirements of the equipment. Fourthly, consider using an isolation transformer at the equipment end. This provides electrical isolation between the underground cable and the equipment. Isolation transformers block the passage of surge currents. However, they still allow data transmission. Fifthly, install lightning arresters at each end of the underground cable. These devices are designed to shunt lightning surges to ground. This prevents them from reaching connected equipment. Sixthly, bond all metal equipment enclosures and cable shields to a common grounding system. This ensures that all components are at the same electrical potential. This minimizes the risk of voltage differentials and surge damage. Seventhly, provide a clear and uninterrupted path to ground for the surge currents. This can be achieved through a grounding rod or other suitable grounding mechanism. The IEEE Standard 1100 2019 titled Recommended Practice for Powering and Grounding Electronic Equipment provides detailed guidance. The TI-AMINUS 1005, a telecommunications infrastructure standard for commercial buildings, offers additional information. The Bixby Telecommunications Distribution Methods Manual 15th edition is another valuable resource for best practices. Understanding these considerations is crucial for safeguarding sensitive electronic equipment connected to underground data cables. Adequate lightning protection not only prevents equipment damage but also ensures the continued operation of critical systems during electrical storms. Consider each of these points in detail for the best implementation of the protection of your system. The use of shielded cables is one of the most effective methods for lightning protection. The shield acts as a Faraday cage, intercepting electromagnetic pulses generated by lightning strikes. When selecting shielded cables, ensure that the shield provides adequate coverage and is made of a conductive material such as copper or aluminum. The shield should be continuous along the entire length of the cable to provide optimal protection. Proper grounding of the cable shield is essential. The grounding should be done at both ends of the cable to create a low impedance path for surge currents. Use grounding conductors of adequate size to handle the expected surge currents. The grounding conductors should be connected to a grounding electrode system that meets local electrical codes. Surge protectors are designed to limit the voltage across their terminals to a safe level. They do this by diverting surge currents to ground. Select surge protectors with a voltage protection rating that is suitable for the equipment being protected. The surge protectors should be installed as close as possible to the equipment they are protecting. Isolation transformers provide a barrier between the underground cable and the equipment. This prevents surge currents from flowing into the equipment. Isolation transformers are particularly useful in applications where the equipment is sensitive to voltage transients. Lightning arresters are heavy-duty surge protection devices that are designed to handle large surge currents. They are typically installed at the entrance of buildings or at other locations where lightning strikes are likely to occur. Lightning arresters should be properly grounded to ensure that surge currents are safely diverted to ground. Bonding is the practice of connecting all metal equipment enclosures and cable shields to a common grounding system. This helps to equalize the potential between different parts of the system. This reduces the risk of voltage differentials and surge damage. Bonding conductors should be of adequate size and should be installed in a way that minimizes impedance. A clear and uninterrupted path to ground is essential for effective lightning protection. The grounding system should be designed to provide a low impedance path for surge currents. Grounding electrodes should be installed in locations where the soil is conductive and the water table is high. Regular inspection and maintenance of the lightning protection system are important to ensure that it is functioning properly. Grounding connections should be checked for corrosion and tightness. Surge protectors and lightning arresters should be tested periodically to verify that they are still functioning within their specifications. In addition to the measures described above, there are other steps that can be taken to improve lightning protection. These include the following: installing a lightning rod system on the building, using fiber optic cables instead of copper cables for data transmission, burying underground cables deeper to reduce their exposure to lightning strikes, implementing a surge protection plan that includes all of the above measures. By taking these steps, it is possible to significantly reduce the risk of damage from lightning strikes. When considering surge protection for data cables, it's important to understand some electrical principles. Firstly, impedance plays a key role. Impedance is the total opposition a circuit presents to alternating current. It's a combination of resistance and reactance. Resistance is the opposition to current flow in a direct current circuit. Reactance is the opposition to current flow due to capacitance and inductance in an alternating current circuit. A low impedance path to ground is crucial for surge protection. This allows surge currents to flow safely to ground without causing damage to equipment. Secondly, grounding is a fundamental safety measure in electrical systems. It provides a common reference point for voltage and helps to prevent electrical shock. A properly grounded system provides a low impedance path for fault currents to flow back to the source. This causes the circuit breaker or fuse to trip, disconnecting the circuit and preventing damage or injury. Thirdly, voltage is the electrical potential difference between 2 points in a circuit. It's the driving force that causes current to flow. Surge protectors work by limiting the voltage across their terminals to a safe level. This prevents excessive voltage from damaging sensitive electronic components. Fourthly, current is the flow of electrical charge through a circuit. It's measured in amperes. Lightning strikes can generate extremely high currents. Lightning arresters and surge protectors are designed to handle these high currents and divert them to ground. Fifthly, inductance is the property of a circuit that opposes changes in current. Inductors store energy in a magnetic field. Surge currents can induce high voltages in inductive circuits. This can damage equipment. Shielded cables and surge protectors can help to reduce the effects of inductance. Sixthly, capacitance is the property of a circuit that opposes changes in voltage. Capacitors store energy in an electric field. Surge currents can charge capacitors to high voltages. This can damage equipment. Surge protectors can help to limit the voltage across capacitors. Understanding these electrical principles is essential for designing and implementing effective surge protection systems. When selecting surge protection devices, it's important to consider the voltage rating, current rating, and response time. The voltage rating should be high enough to handle the expected surge voltages. The current rating should be high enough to handle the expected surge currents. The response time should be fast enough to protect sensitive electronic components. In addition to surge protection devices, other measures can be taken to reduce the risk of lightning damage. These include using shielded cables, grounding equipment properly, and installing lightning rods. Shielded cables help to reduce the amount of electromagnetic energy that is induced into the cable by lightning strikes. Grounding equipment properly provides a low impedance path for surge currents to flow to ground. Lightning rods provide a path for lightning strikes to flow to ground without damaging the building or equipment. Regular inspection and maintenance of surge protection systems are essential to ensure that they are functioning properly. Surge protectors should be tested periodically to verify that they are still working. Grounding connections should be checked for corrosion and tightness. Lightning rods should be inspected for damage and corrosion. NEC Article 800 covers communication circuits. NEC Section 800.100 requires that metallic communication cables entering a building be grounded as close as practicable to the point of entrance. The grounding conductor must be connected to the building's grounding electrode system. NEC section 800.100p specifies the size of the grounding conductor. It must be at least 14 AWG copper or equivalent. NEC section 800.100c specifies the grounding electrode. It must be one of the following: the building's grounding electrode system, a ground rod, or other electrode permitted by NEC section 250.52. NEC article 250 covers grounding and bonding. NEC section 250.45 requires that non-current carrying metal parts of equipment be bonded together and connected to the grounding electrode system. This creates a low impedance path for fault currents. NEC section 250.24 requires that the grounding electrode conductor be connected to the neutral conductor at the service entrance. This is called the main bonding jumper. NEC section 250.50 requires that all grounding electrodes be bonded together to form the grounding electrode system. This includes the building's grounding electrode, any ground rods, and any other electrodes permitted by NEC section 250.52. NEC section 250.52 specifies the types of grounding electrodes that are permitted. These include metal underground water pipes, metal building frames, ground rods, and ground plates. The choice of grounding electrode will depend on the specific site conditions. Proper grounding and bonding are essential for electrical safety. They help to prevent electrical shock and fire hazards. They also help to protect equipment from damage due to voltage surges. When installing underground data cables, it is important to follow all applicable electrical codes. This will ensure that the installation is safe and reliable. In addition to the NEC, there are other standards and guidelines that may be applicable. These include the IE 1100 standard, the TI-1005 standard, and the Bixby Telecommunications Distribution Methods Manual. These resources provide more detailed information on grounding, bonding, and surge protection. Consider a scenario where a building houses a critical data center. The data center is connected to another building via an underground unshielded data cable. During a thunderstorm, a lightning strike occurs near the underground cable. The lightning strike induces a large voltage surge into the unshielded data cable. This surge travels along the cable to the data center. The surge damages the network equipment in the data center. This causes a disruption to the data center's operations. To prevent this from happening, the underground data cable should be replaced with a shielded cable. The shield of the cable should be grounded at both ends. Surge protectors should be installed at both ends of the cable to protect the network equipment. A lightning rod system should be installed on the building to protect it from direct lightning strikes. The building's grounding system should be properly installed and maintained. By taking these measures, the data center can be protected from lightning strikes and the risk of disruption to its operations can be reduced. In another scenario, a residential home has an underground data cable running from the house to a detached garage. The data cable is used to connect the house to the internet. During a thunderstorm, a lightning strike occurs near the underground cable. The lightning strike induces a voltage surge into the data cable. This surge travels along the cable to the house. The surge damages the modem and router in the house. This causes the loss of internet service. To prevent this from happening, underground data cable should be replaced with a shielded cable. The shield of the cable should be grounded at both ends. Surge protectors should be installed at both ends of the cable to protect the modem and router. The home's electrical system should be properly grounded. By taking these measures, the home can be protected from lightning strikes and the risk of damage to its electronic equipment can be reduced. When dealing with existing unshielded cables, mitigation becomes more challenging. Instead of cable replacement, focus on enhancing surge protection at both ends. High-quality surge protectors with robust Joule ratings are essential. Ensure these protectors are properly grounded. If possible, add a dedicated grounding electrode system near the equipment being protected. This provides a more direct path for surge currents to ground. Consider using media converters to isolate the network electrically. A fiber optic media converter transforms the electrical signal to light. This prevents surges from propagating further into the network. Regularly inspect and test the grounding system. Check for corrosion or loose connections. A weak grounding system can compromise the effectiveness of surge protection. Educate users about the risks of lightning strikes. Advise them to disconnect sensitive equipment during thunderstorms. Even with surge protection, direct lightning strikes can cause significant damage. Monitor local weather forecasts. Be prepared to take proactive measures during severe weather events. Finally, consult with a qualified electrician or lightning protection specialist. They can assess the specific risks and recommend the best solutions. A professional assessment ensures that the protection measures are appropriate for the location and equipment. Consider that lightning protection isn't a one-time fix but a continuous process.